When we store or ship solutions, we ship them as a concentrated stock solution. The reason for this is because water takes up a large volume. It also is very heavy. And so it's a lot more efficient and economical to ship smaller volumes that have less weight, but that means that they are more concentrated. So to make the solutions into a lower concentration that gets used in the lab, we have to add more solvent to it. So the amount of solute does not change, but by adding more solvent, that increases the volume of the new solution. But the moles stay the same. So the moles of the solute are equal to the moles of the solute in solution 2. In order to do our calculation, we're going to use the equation M1V1 equals M2V2. Now remember, molarity is moles over liters, and if we multiply by a volume, you'll see the volumes cancel, and essentially what we're saying is that the moles are equal to each other. This is a very important concept. If you're working in labs dealing with solutions, you will probably have to make dilutions. So this is a vitally important equation for you to remember. And this works not only for molarity, but any concentration. So you may see it as C1V1 equals C2V2. To what volume should we dilute 0.2 liters of a 15 molar sodium hydroxide solution to make 3 molar? So again, we want to use our M1V1 equals M2V2. The key to doing these problems is making sure you get the concentrated solution on one side and the dilute solution on the other. It isn't important which side is which, just that those values go together. So our 15 molar, that is our concentrated molarity. We know that because it's a larger number than the molarity that we're trying to make. So we are going to put 15 molar on one side. We're going to multiply by 0.200 liters because that is the volume of our concentrated solution. The molarity that we're trying to make is 3 molar, and we are trying to find V2. And so we would have to divide by 3 molar to get our V2 by itself. And we would end up with 1 liter of solution. Now, if we think about this, we are decreasing our molarity by 5 times, which means that we have to increase our volume by 5 times. So this does make sense as an answer that we would have 1 liter of our diluted solution. Here's a practice problem for you. See if you can figure out how to prepare 200 milliliters of a sodium chloride solution. Again, we are going to use our M1V1 equals M2V2. We want to put concentrated on one side and dilute on the other. Right? So we're trying to prepare 200 milliliters of a 0.25 molar. So this is a smaller number. That's our dilute side. So 0.25 molar is our dilute concentration, and we're trying to prepare 200 milliliters of that solution. It says our concentrated molarity is 2 molar. Now to get the V1 by itself, we divide by our 2 molar. And so our V1 is going to be equal to 25 milliliters. Now you may ask, well, didn't I have to change the volume into liters? Well, because if we look at our units, the molarities cancel. Whatever unit our volume is in, that's what we get back as an answer. So it doesn't matter what units your volume is in, just that they're the same between both sides. This also introduces a concept of millimoles. So if you take molarity and you multiply by milliliters, because it's 1,000 times smaller, you end up with something 1,000 times smaller than a mole, which would be a millimole. And this is perfectly fine to do this. You just want to make sure that you are consistent in your units when you're using them.